In this section here, we're going to be working some examples in logarithmic differentiation. And we're going to start with y is equal to x plus 1 quantity squared over x minus 1. And we want to find y prime. And so what we're going to do here is we're going to take the natural log of both sides. Now we're going to use the properties of natural logs to break this thing up. So I got the natural log of y is equal to the natural log. Now I'm going to take this 2 and go ahead and bring it on out front. X plus 1. Now we have x plus 1 squared over x minus 1, so we're going to use a minus. The natural log of x minus 1. So hopefully you're up on your log properties, or that might make this a little difficult to understand what I'm doing. Now what we can do is go ahead and take the derivative now. So the derivative of y is 1, and then we rewrite y times, now because we're taking the derivative of y, I'm going to write dy over dx here. And I guess I should have said in the beginning, instead of finding y prime, or this is the other notation, we're trying to find dy over dx. So now I'm going to take the derivative of this term here. So we got derivative of x plus 1 is 1 over x plus 1 minus derivative of x minus 1 is 1 over, rewrite, derivative of x minus 1. Now what I'm going to do here is solve for dy dx, and that is I'm going to multiply both sides by y, and so we're left with dy over dx is equal to, I'm going to go ahead and bring that 2 up on top, and I'm going to go ahead and put this whole thing in parentheses, and we're multiplying both sides by y. So there you go. Now to get everything in terms of x, what you want to do is, we know what y is equal to, right? Y is equal to this here, so we're going to substitute this y right here in for our original problem. So that's going to become now dy over dx is equal to 2 over x plus 1 minus 1 over x minus 1, and then of course the original was y was equal to x plus 1 quantity squared over x minus 1. And of course, you can simplify all this down, but I don't really get caught up in a bunch of algebra right now, so we're going to leave it like this. So that's using logarithmic differentiation. Alright, so let's look at another example. So we have y, try this again. We have y is equal to x times the square root of x squared minus 1. And we want to find dy over dx. and we're going to use logarithmic differentiation to do it. So the first thing I'm going to do is I'm going to go ahead and rewrite this. Y is equal to x, getting this out of radical form, putting it in exponential form. Now I'm going to take the natural log of both sides, and now I'm going to use those log properties to expand this. So we have the natural log of x plus, because this is a product, of the natural log of x squared minus 1 raised to the half. And I'm going to rewrite this one more time. I'm going to take this half and bring it out front. Now I'm not taking the derivative. That's just properties of expanding the natural log function here. Okay. Now I'm going to take the derivative. So derivative of y is 1. We rewrite. And I'm going to write dy over dx because we're taking the derivative of y. The derivative of x is 1. Rewrite. Plus, I have a half times the derivative of x squared minus 1 is 2x over, and then rewrite. Right, taking the derivative of the natural log function. Now what I'm going to do here is multiply both sides by y, so we have dy over dx is equal to, and I'm going to start a parentheses. We have 1 over x plus, I have a 2 down here in the denominator, 2 up in the numerator, so I'm going to cancel that 2 out. We have x squared minus 1, and because I'm multiplying both sides by y, we're going to put that y right there. Now I'm going to go ahead and substitute back in this y right here with the original. So this would be dy over dx is equal to 1 over x plus x over x squared minus 1. And remember what our y was originally equal to. Alright, and you can simplify this down if you want, but I'm going to leave it just like it is. So that's taking the derivative, okay, of y with respect to x, but we're using logarithmic differentiation to do it. Now what you ought to consider doing is taking the derivative of this the old-fashioned way and seeing if you get the same answer. You know, you're going to need to simplify this all the way down to compare your answers.